All right, so the population is divided into two groups, those who have the disease and those who don't, right? Now, there's a 10% chance that a person picked at random has the disease, a 90% chance that a person picked at random doesn't. So this is D, this is D complement. Then, if you have the disease, there is a 90% chance that you test positive for it, and a 10% chance that you test negative. If you don't have the disease, there's a 10% chance that you test positive and a 90% chance that you test negative. What we're putting here are conditional probabilities. So what is the probability that somebody is in this group? That is, has the disease, tests positive. Multiplication rule says the chance of D intersect T, the chance you have the disease and test positive, is the conditional probability that you test positive given that you have the disease, that's 90%, times the unconditional probability that you have the disease, that's 10%. So the amount of probability that's down here, this node, which has the disease and tests positive, has probability 0.9 times 0.1, which is 0.09. Right, 9%. Okay, these people have the disease and test positive. 9% chance of that happening if you pull a person at random and test them. Right? This is has the disease, tests negative. Right? 10% is conditional probability that you test negative given that you have the disease. 10% is probability you have the disease. So probability that you have the disease and test negative is this conditional probability times that unconditional probability. 0.1 times 0.1 is 0.01, 1%. Yes? So this is 1%, and that is D T complement. Then here, this is don't have the disease, test positive. Probability of that intersection is this conditional probability times that unconditional probability. 0.1 times 0.9 is 0.099%. So this here is 9%, and that event is D complement T. And then this pile here, probability that you don't have the disease and test negative is the conditional probability that you test negative given that you don't have the disease times the unconditional probability that you don't have the disease. We have 0.9 times 0.9 is 81%. Yes? And that is D complement T complement. And just as a sanity check, do these add up to 100%? Yep. 81 and 9 is 90 and 10 is 100. Yeah? Okay. So this is a good thing. All right. So what are we interested in? We're interested in the probability that you have the disease given that you test positive. So which of these branches of the tree corresponds to testing positive? The ones that have a T in them, yeah? Not a T complement. So that's this, and I think I'll draw that to include the probability, that, and that. Yes? Okay, so when we condition on the event that the person tests positive, we're limiting the universe to these outcomes where somebody tests positive. Of those, what fraction actually have the disease? It's 50%, right? It's 9% divided by the 18%. 18% of people are going to test positive. Of those, half, 9% actually have the disease. The other half are false positives. This make sense? Okay, so what we've got is probability that you have the disease given that you test positive is probability that you have the disease and test positive divided by the probability that you test positive. We have partitioned the event that you test positive into two pieces. You can test positive two ways. You can test positive and have the disease, or test positive and not have the disease. Those are the only possibilities, right? So this denominator is, the numerator is still p of dt. The denominator is p of dt plus p of d complement t, right? We've partitioned the event t into two disjoint pieces, t and d, t and not d. Yep. And what we just did, this is equal to 9% over 9% plus 9%, and that's a half, right? Okay, so even though the disease is even though the test is 90% accurate, the conditional probability that you have the disease, given that you test positive, is only 50%. Okay? Because a lot of the positive test results are false positive test results. Okay? So you need to take the base rate of occurrence of the, in this case, the disease, into account in figuring out what the chance is that a person has the condition given that they test positive for the condition. The base rate matters.